Alright, as we start chapter 12, we're going to skip section 1 and we'll pick up on section 2. Now, this is a sort of a long one, so it may be in two parts, but we'll see how we go along. So, solving quadratic equations by factoring. We did some of this way back a long time ago, but we can also introduce a new technique, solving quadratic equations by using the square root property. And then we will solve quadratic equations by completing the square. And we will write quadratic equations given the answers, the roots. So let's get started. So we had said a long time ago that if you have a factor A and a factor B, and the product of this was a 0, the only way that could be true is if the factor A or the factor B or both were a 0. So this is a technique we're going to use, and for some this is a review. It's called the zero factor property. You want to have that in your notes. So, in this method, if you have a quadratic equation, and it's in standard form, where A, B, and C are real numbers, and A does not equal 0, then one of the methods for solving it will be by factoring this trinomial and then equating the factors to 0. And we'll go through that step by step. And they're going through the process here as we go through these points. So one of the first things we are to do is to put an equation in standard form. So that would be x squared minus 15x. Take our negative 50, bring it to the other side as a positive 50, and then equal that to 0. So this is the quadratic equation in standard form. And now we're going to factor it. So these usually aren't too difficult to factor. This would be a 10 and this would be a 5. 5 times 10 is 50, and if we add our outers and inners, that should add up to 15, and this is positive, this is negative, so both of these need to be negative. So then our next step is to equate each of these to 0. X minus 5 equals 0. Or x minus 10 equals 0. Remember, this is sort of like our A times B equals 0. That's the zero factor property, where one of these factors or both have to be equal to 0. And this is the technique we use. So here we get x is 5, and here we get x is 10. This is a quadratic equation, so we need two solutions. Okay, let's check it out here. And they both work. Okay, now let's take a look at this one. So again, is it in standard form? And the answer is no, so we have to put it in standard form. So 3x squared minus 24x. Transpose this to the other side, positive 48. Now, can we, and that equals 0, can we factor out a 3? Yes. Now there's a couple of ways to do it. One way is divide everything by 3. And that way it cleans it up nicely. This is x squared minus 8x. And then this will be plus 16. So again, now we're looking for factors that will add up to 8. And we get x and x, 4 and 4, minus and minus. Okay. Now, we would have had, if we factored it the other way, a 3 out there, but we would just disregard that. And now we have x minus 4 equals 0, and x minus 4 equals 0, so x equals 4. Now we actually get this twice. When you have it twice, you only need to list it once. And that works. We did it a little differently. Actually, this is a perfect square trinomial. We did it the other way, but that's all right. Any way that works. And it does check. Now, as we look at example 2, since this is the sum of perfect squares, the sum of perfect squares doesn't factor. So you cannot solve this by factoring. Now, they're introducing something we haven't introduced lately, or yet, as far as I know in this term, and that is imaginary numbers. And write this down, and we'll take a look at this a little later here. Note that the sum of two squares can be factored into the product of conjugates of complex numbers. Okay, but we haven't had that yet, so I'm going to have to check this out. I'm making this before the course starts, and I had the idea they weren't going to do complex numbers, but they're introducing them here. So here, the answers would be a negative 2i and a positive 2i. And what you might say, where'd that I come from? Well, that's the imaginary number. And just so you don't have too much wondering here, the I equals the square root of negative 1. We had said throughout this course so far that you can't have the square root of a negative because that is not a real number. And this is not a real number, but it is what we call a complex number. And we haven't introduced those yet, but that's what they're showing here. More information when we get to this in class. And it does check. Okay, now we're going to introduce what is called another way to solve quadratic equations. And that is, in this case, the square root property. And what is that? Well, if you have, as they're showing you here, I'll write it over here, x squared equals c. Now, we can take the square root of this. We had that before. and that gives us x. And on this side, it would give us the square root of c. So we would say x equals the square root of c. Now, we needed, since this was initially a quadratic equation, we need two answers. Well, what I've done here so far, we're only getting one. So this is where we will introduce that whenever you take the square root of this side, in order to get the two answers on the other side, we go plus or minus the square root of the other side. Okay? And that is called the square root property. And that's what they're describing here. Now, a modification of this is, suppose you have something that looks like this. And we had talked about this a long time ago, that this is a binomial square. And if we expanded that, we'd get a trinomial. But in this form, that it's a binomial that we're going to square, we could take the square root of this and get the radicand. We've done this before. And then that would equal plus or minus the square root on the other side. And then we just transport the a over, and that would be a positive a. And then we would have x equals something that looks like this. But I may be getting ahead of myself and just going over this process here. So let's see some in our examples here. So, let's see what we have. Now, I'll write it out here. Y plus 4, the quantity squared, equals 8. Giving myself lots of room here. So I said to take the square root of this, whatever the index number is, and that, it just becomes the radicand, which is y plus 4. And then we take plus or minus on this side the square root of 8. Now you might remember that the square root of 8 was the square root of 4 times the square root of 2. Doesn't that bring back memories? So far then we have here plus or minus 2 the square root of 2. And on this side we have y plus 4. Well, we're going to transpose the 4. On this side it will become a negative 4 plus or minus 2 the square root of 2, and that is what y equals. So we're using this square root property now, and we're squaring this binomial. We're building up to something here. And there's your answer. Notice they are simplifying the square root of 8 from an earlier lesson. Now, again, as we look at this is going to be a little bit interesting. X squared equals a negative 25. So we take the square root of this, that'll give us x, and then this equals plus or minus the square root of a negative 25. But we know that's not a real number. Now, I'm going to introduce this a little bit here, that when that happens, what we do is we go plus or minus the square root of negative 1 times the square root of 25. Now, I slipped this in a little earlier, the square root of -1 we said was equal to the letter I, which is this imaginary number that stands for this. So this then becomes plus or minus I, that's this I here, the square root of 25. Now we can take the square root of 25 and we get plus or minus 5I. So that's where that I comes from, as we kind of convert this imaginary number here to a complex number with the letter I. And they're not showing us everything, just giving us the answer. Okay, now for this one, we're moving on to a process that we use a lot, which is called completing the square. So let me take you through this in some detail. And keep in mind this: ax squared plus bx plus c. And I'm going to get rid of the a because we don't need that right now, because a is 1 here. Now this is a quadratic expression. We would like this expression to become something that looks like this: a plus something here, that when we square it will become a perfect square trinomial that we will be able to factor into a binomial that we would square. So this is the first part of it, and we're using this process completing the square. So what we need here, we have the x squared, we have bx, and what we're missing here is our what we call our c term, this c term here, and we want it to become this. Now that special technique that we've mentioned a number of times, that we will square this binomial. Well, the first thing we do is we square whatever is here to get x squared. So this is just going to be x. And then we use the sign that's in the middle. And then what do we do to get our middle term? Well, we multiply this times what's here and then double it to get this term. Now, if I doubled something to get the 10, how do I undouble something? Think about it. And if you said divide by 2, that's exactly the answer. So 10 divided by 2 is 5. So now we have our binomial, but what we don't have is our new c term, the term that's missing. And how did we get that c term? We got that c term by squaring the 5. So this is going to end up being a 25. And going through this process I've just described is called completing the square. We had the first two terms. We needed to do things to get our third term, our c term, that caused us to complete the square. Okay, let's see what they're going to say. So, what do we need to put that when we factor this is going to become a perfect square trinomial, will be a binomial that we square? Well, remember, we take half of the b term and get 5. So the x plus 5 goes there, and then we square the 5 to give us our c term, 25. Okay, that's the process. Now, if they're all that easy, that would be really cool, but they do get a little more complicated. And we'll pick up this as we're just running 20 minutes. So we'll start part 2, where we'll do this one in just a few moments.